My name is Garland, and today we'll be talking about building cost visibility for a Kubernetes cluster. A little bit about who I am. I've been kind of in this DevOps infrastructure back in cloud scaling space for over 10 years. Last couple of years, been helping a bunch of companies move on to a containerized workflow, and then more recently moving into a Kubernetes platform for scaling. And what Managed Coop does is we create productivity tools for DevOps people, and one of them is a Kubernetes Slack bot. It helps you save time, troubleshooting, automates your DevOps workflow, and then also bring kubectl-like information into Slack. So today we'll go through why cost visibility, what you can do, some of the tools out there that can help you out, how these tools work, and then some tools to help you cut costs once you can measure and quantify these things. So why cost visibility, right? Once you're on like this Kubernetes kind of type infrastructure, eventually someone's going to ask, how much is this stuff costing me? What are the application costs that are running in this cluster? And so with Kubernetes, it's a kind of a shared cluster. There are workloads running on it that are running on the same node, the same workload on the same node. So you can't exactly just quantify the cost of these things by just looking at your cloud provider bill. And then also that there also tends to be like three segment of people, management, DevOps, and developers that are kind of interested in this type of information. The management types are interested in like the top level costs, what does everything cost, and then maybe a breakdown in namespaces where applications or certain teams are kind of living in. They want to know those segment of costs for people. And then the DevOps people want to know that, and then also the cost of a pod. So a pod, you can kind of equate that to a server. And so DevOps are kind of interested up and down this stack because you want to know the high-level costs, the low-level costs, and everything in between, just so that you can speak about the system to make it more efficient, et cetera. And then there's the developers, application owners, product teams. They're usually only interested in their own application, right? Like they don't really care about the cluster. They usually might not even care about the platform that it's running on, but they do care about their application and what the cogs are that going into their application. So with this information, you get to do stuff like forecasts and budgeting for the teams, applications, and different groups. You can better utilize your cluster by knowing this information to reduce costs in certain areas, or if there's outsized costs in a certain area, you can start looking at that and try to optimize that and reduce that. And then also understanding product margins, right? Like you can't, create product, don't know your product margins unless you know what kind of goes into the cost of the products. So the cost breakdown in Kubernetes isn't really provided by your cloud providers, right? So a lot of times, the cloud providers don't know you're running this thing called Kubernetes on top of their nodes, and they really only show you what they're kind of billing you. So there's an example of a AWS billing report, right? So they're really good at slicing and dicing items that they charge you for, but then they're really selling you nodes. And they don't know that you're running Kubernetes, and they don't know what you're actually doing on top of that on there. So they don't actually know the containers that you're running in the nodes, and then hence they don't kind of report on it because they're really not charging you for that level of abstraction. So to kind of understand why, we look at kind of how Kubernetes works. So the cloud provider kind of charge you, and you're renting nodes from them, right? Like node A and node B. However, we're running this thing called Kubernetes inside of it, and in Kubernetes land, there's these things called pods. You could kind of equate pods into a server, per se. And these pods are containers that are running on these nodes, and then Kubernetes schedules these pods onto one or more of these nodes per your requirement. And then on top of that, there's this thing called namespace. Namespace is more of a logical segmentation you would create a namespace for an application or an application group, and you would let them control this namespace so that they can deliver whatever containers that they want into this namespace without having to worry about this underlying infrastructure. So these namespaces usually tend to cross node boundaries. So the cloud provider don't know that you're really doing all this stuff on top of the nodes, and they're really not charging you for this kind of stuff either, right? So these items don't show up in your cloud bill. So now that we know that what we're kind of want to measure and look for, what are some of the tools that are out there that can really help us get this type of information? We'll quickly first go over some commercial offerings. Cloud Health is one commercial offering. They have an agent that talks to your Kubernetes API, gets the information from your Kubernetes API on what namespaces are out there, what pods, what containers are running on your cluster. And then it quantifies this information and breaks it down by pods and then aggregates it up to a namespace and then ultimately aggregates that up to a cluster where you can get a granular view of what each layer costs. There's another tool called Cloudbility. It does fairly the same thing, right? And it works fairly the same way. It gets you pretty much the same type of information. So these are commercial offering, and they tend to be fairly expensive. They're usually 1% to 3% of your cloud monthly bill. That's what they charge. And they're just really not for Kubernetes, right? Like they're there to look at your entire cloud cost bill. They'll look at everything, all the resources in your cloud, like RDS, SQS, Lambda, et cetera, and then give you a really nice dashboard on how to slice and dice it for each consumer, if it's management, DevOps, or the developers. And then there are starting to get like free tools. So earlier I said that cloud providers don't give you this type of information. That's not totally accurate. I mean, they're starting to give us this type of information, but just really not integrated into the cloud bill, right? So for example, GKE, if you're on Google Cloud and you're using GKE, there's this thing called metering, which is free. And it'll suck everything in from your cluster and put it into BigQuery and allow you to visualize it. And it'll give you the same type of information. Pod costs and namespace costs, and ultimately group that up to a cluster cost. However, this tool is still not integrated into the billing aspect of it. So maybe that's okay because they're really not billing you for this stuff, right? Like GKE resource doesn't cost you any money. They're really charging you for the instances that you're running on GKE. Then it gets into some of the open source things that you can do for free. There's this Grafana dashboard by Carl Stoney. It was released a while back ago, but it still works fairly well. It's a Grafana-based dashboard that uses Prometheus and Kubernetes state metrics to gather this information up. So gather all the information up, like how many nodes you have, how many pods you have in your cluster, and then calculate the cost. So this one's a little manual where if you see on top, you see the CPU and everything like that. You put in your own cost assumptions on that, right? Like if you're using this type of nodes, this type of CPU, you would put in the cost of these items, and if you were getting a discount on it, if you were using a lot of cloud resources, usually if you talk to your cloud, you would get some kind of discount. You can plug all that stuff in, and then it will do the calculation dynamically and give you a summary of what your costs are. Then there's another tool called Coop Resource Report. This tool doesn't rely on any third-party resources. It's a single thing that's deployable into your Kubernetes cluster. And it also gives you a web front interface that will show you your Kubernetes costs. So it does basically the same thing. It gives you your pod costs, your namespace costs, and ultimately aggregates up to a cluster. And then finally, there's CoreOS operating metering. It's more enterprisey-like. There's no built-in dashboard that is included in with it. However, it does give you a very powerful reporting engine that it grabs all these metrics, puts it in a database so you can query it, report on it, push it into other dashboarding tools that you might use in your enterprise to visualize and report on metrics. And then here's a tool comparison of the tools on what is paid, what is open source, how easy it is to use. And arguably, I think Coop Resource Report is one of the easier ones to use because you don't need any other third-party resources and integrate it with anything else. It's single installable. You can install it into your cluster and pretty much immediately get a web interface to look at your cloud costs and kind of click through it and everything like that. So let's talk about a little bit how these tools work. So one problem is that if you were to install any one of these tools and then you went and added up the pod costs and then you were trying to equate it to what the cloud provider is billing you, you find out that these numbers don't match up. And they don't match up because it's really how these things are calculated, right? And then we'll have to kind of dig into a little deeper on how these things are calculated. So I was saying that like the Carl Stoney tool, it uses Prometheus and Coop State Metrics, and even the commercial tools or Coop State Report goes and talks to the Coop API to get this information. And it really uses this thing called the CPU memory request or limit parameter. This is a parameter that you can set on your pod to request some kind of CPU, like 1 core, half a core, 2 cores, or 4 gigs of memory, 8 gigs of memory that you are requesting on the cluster. And this is a minimum request, so the cluster has to be able to find resources on the cluster to be able to schedule this out. So this makes that a very good number to calculate costs on, because you have to calculate costs on something, right? You have to calculate costs based upon some CPU usage or CPU requests or what I'm actually trying to guarantee your nodes. And this is exactly how most cloud provider charge you for resources, right? They're selling you number of CPU, number of memory, hard disk space, and then they charge you by network bandwidth and things like that. So in the same thing, Kubernetes, is the same thing, but it's a little higher abstraction level than VMs. But at the end of the day, that makes it a very good metrics to calculate usage on. So talking a little bit more about the CPU memory limits, they are optional limits, optional settings that you can set on your pod. So you're really requesting a certain limit on the pod that you want. And these are minimum limits that it has to be able to adhere to. So let's look at some of the open source tools that are actually reporting on this. Like, for example, the Coop State report on how it is actually calculating these cost numbers. So if you look at it, it is taking the CPU request here, and then multiplying it by the cost per CPU. And then it does that for the same for the memory, which gives you, your cost number here. And then it just sums it all up. All right. And then, so Coop State Report also gives you this interesting metric called slack. So the slack cost is the number of the CPU and memory amount that you have requested minus the actual usage of your CPU or memory. So that gives you the difference between on what you're actually not using. So this is an interesting number because let's just say I've requested 4 CPU and the thing is actually only using at any given moment 1. So I'm arguably wasting 3 CPUs at that time, right? I've actually requested that many CPU that is allocated and dedicated to me, but I'm not using it. So that's an interesting number because then it gives us the waste that we're using, but it is a little hard to use that number verbatim because there are so many variables, right? Like you always need some buffer in your CPU memory, so when there's more traffic coming in, when there's higher load, that it can burst. And then there's, how do you horizontally or vertically scale these things, and what's the buffer? So kind of with like all things, it's not as straightforward as you think it should be, because there's just so many variables, right? If you don't have everything else in place, it doesn't make sense to squash that number to 0, because then you're either going to get an OOM when there's more traffic that comes in and it tries to grab more memory, or it's just not going to be able to scale properly. So what do these tools, provide us with? They provide us with a number that's very close to what the cloud provider is charging us. It provides us with something that we can use as a baseline to compare one pod against another, one namespace against another, and one cluster against another, to do more apples to apples kind of comparison on that level. But then it also gives you, some metrics to start reporting and making decisions on from these numbers. So once we, have these numbers, the next thing is to cut costs, right? Like, how do I make this more efficient? How do I reduce costs based upon these numbers, and how to, reduce these numbers altogether, right? There are a bunch of cost-cutting tactics that we'll kind of go through kind of quickly. Cluster autoscaler, and these are all like Kubernetes type of things. Setting namespace quotas and stuff like that. So what the Kubernetes autoscaler is, if you're kind of familiar with like AWS autoscaling group, it's kind of like that, but for your cluster. So when you say, hey, Kubernetes, turn me on some pods on here, you might or might not have the resources, the node resources in the cluster to make that happen, right? So your cluster is going to be like, hey, these things are in pending state. You wanted 3 ambassador things. 1 is running, but 2 are in pending state. Then there's this thing called a cluster autoscaler that watches your Kubernetes API and to see what kind of events are happening and what it wants to do. It will notice that you did try to scale up this thing, and then there was insufficient CPU there. So trigger upon that and increase the node count on the cluster. So it is, so most of these Kubernetes clusters are kind of cloud aware. They're hooked into your cloud provider, be it GCP or AWS, and then they'll increase the node count if you're doing like auto-scaling groups or instance groups. It'll increase the node count on that so that it can, so this pod can be scheduled out. And on the flip side, it'll do also the same, right? When you turn these pods off, it will notice that, hey, there's extra capacity in the node, and then it will turn these nodes off or move workload onto different nodes and turn it off to help you scale it down. Then there's resource quotas for the namespace. So this doesn't necessarily reduce costs, but it helps you kind of contain costs. So usually once you have this deployed out widely, and application groups have taken ownership of a namespace, and then they're doing their thing in this namespace, deploying their API, web front end, or whatever they want to deploy in there. Sometimes they go a little crazy, right? Like they start deploying everything in there, and then start consuming a lot of CPU and memory. And then sometimes also automation kind of goes haywire, right? I can punch in an extra 0 in there from 10 to 100, right? Like that's very easy to do. And then all of a sudden the system might scale this thing out to 100 or 1,000 pods, which then if you had the auto cluster scaler enabled, then this thing will just keep on growing and growing. So to kind of prevent that, you can set resource limits on pretty much any resource in Kubernetes. So you can limit CPU, memory, and other non-cost attributed resources. So this is a very good thing to kind of set up. And then the next thing is a kind of pod autoscaler. The pod autoscaler kind of works in conjunction with the cluster autoscaler. The pod autoscaler is kind of similar to the autoscaling groups in AWS, right? But this is on a Kubernetes pod level. So you can scale on any type of metrics. One simple metric is CPU. So you can say, you can tell Kubernetes, like, if the CPU in aggregate for this pod goes over X, start scaling out this pod. If, on the flip side, if it goes under X, on aggregate, start downscaling the pods. So with that, you can, at load time, it will scale down to some level, and then, when load starts to increase, it will start scaling out. And in conjunction with a cluster autoscaler, because pods are really just a virtual thing that's kind of sitting there, right? These pods eventually needs to run on a node. And so this cluster autoscaler usually would scale out the pods, and then it would sit in a pending state until, if there's no resources on the cluster, until the cluster autoscaler increases the node count, and then allow these pods to be scheduled on to the nodes. And then, of course, there's the spot and preemptable type instances. These are kind of extra capacity type instances that can be taken away from you at any given time from the cloud provider. These are very good instances to use because they can be up to like 80% off of the regular on-demand type pricing. But however, you have to be careful using it because they are extra capacity type instances, and the cloud provider can reap these from you pretty much at any time. So you do have to have other schemes in place so that you protect yourself from starving out your entire cluster of node resources. And then if you're on AWS, there's the reserve instances, which are instances where you can put an upfront type commitment on a term and even monetary upfront payout. So you're basically buying a portion of the compute and paying to the cloud provider what you want to use up front. And then for that, you get a very discounted or a variable discounted rate on what the hourly instance cost is. So this, you can get up to, like 60 or 70% off of the cost by, putting up some upfront money. But to do this, you really have to quantify and plan out and forecast out what you're going to do, right? Like you're not going to put down some money for a 1 year, 2 year, 3 year term without knowing that, hey, I'm going to use these instances for that long. But however, they've made it a little bit more flexible nowadays where there are third-party markets where if you did buy a 3 year term, you're not using anymore, you can resell those at a little bit of a loss. Yeah, so today, it's like summary of it is like understanding cloud costs and in particular Kubernetes costs in general. On top of that level is it's important because you do need to know how to forecast and plan costs for your application. How are you going to grow? What kind of resources that you're going to need going in the future. Yeah, thanks. Email me or find me, if you guys want to talk about Kubernetes anytime. Anybody have any questions?
Yeah, so I was just wondering, just a bit of a technical question, I guess, about cluster autoscaling. So I've never used it myself, but is it possible to schedule spots of scaling at specific times? Like if you knew a big event was coming, or if you have a developer environment that you want to scale down at the weekend or something like that?
Right. Yeah, so the cluster autoscaler is a sub-project of the Kubernetes. So currently, right now, there are no contexts to have any schedule scaling like you talked about. However, I think I have seen third-party tools that will help you kind of scale that out, but I couldn't give you the name of it.
Yeah, I was wondering the intersection between Istio and the Coop resource report, or is there any real, like with the visibility from Istio?
Yeah, there's no intersection with that. Istio is a service mesh that gives you, Gotcha. Yeah. So it doesn't really give you the cost, right? Like it doesn't break down the cost. While these tools here that I've shown you, like the Coop resource report or the Carl Stoney thing, it kind of tries to quantify the costs on the pods. Cool. Any more questions? Thanks, guys.